Hi guys, this is Dr. P and today we want to solve the problem number 27 from Math 3 end of course exam. So David plans to cover the floor of his room with new material. The floor is an isosceles trapezoid whose bases are 16 and 26 and sides are 13 feet. Each piece of new material has an area of 22.5 square feet. Assuming the new pieces of material can be cut as needed, how many pieces does David need? So here is the isosceles trapezoid. Do we have the bases, both bases? Do we have the congruent sides? And do we have the area of a piece? So how many pieces do we need to cover this floor means that we should calculate how many pieces are embedded in the surface. So that's why we need the area of the surface. So we have the bases, the big base is 26, the small base is 16. So that's why we need the height. The height of the trapezoid, so these heights are equal. We have also here a rectangle, so that's why this part is 16 and we try to find out these small parts. Of course, these two right angle triangles are congruent because they have the hypotenuse is congruent and one leg congruent. So that's why we can state that these segments are congruent. Let's say the length of one of these to be x. So first I will find the x. So x plus 16 plus x will be equal 26. So let's set up the equation and let's solve it. To isolate x, we will subtract 16 from both sides and x plus x is 2x. So 2x equals 10. Of course, divided by 2 on both sides. So x equals 5. So at this moment in my triangles, I will replace here the value with 5. So these segments are 5. And now if I'm looking in a right angle triangle to find the height, I should apply the Pythagorean theorem. So hypotenuse square 13 square equals leg square 5 square plus the other leg square height square. So 169 equals 25 plus height square. Subtract 25 to isolate. You have 144 equals height square. Apply the square root. So we have 12 equals the height. And now we are able to calculate, of course, the area. So area of the trapezoid will be the sum of the bases. So we'll have 26 plus 16, everything multiplied by the height, which is 12 for us, and divided by 2. So area equal 42 times 12 divided by 2. So if you calculate, of course, this number, you can simplify or you get 252. And the final step to find the number of the tiles, we divide the area, the measure of the surface of the trapezoid by the area of a tile. So 252 divided by 2.5, you can use a calculator and you get like 100.8, and that's why we will approximate this to 101 because in fact there are these represent the number of tiles, so should be an integer. So that's why our answer will be obviously A. Thank you for watching this tutorial.